Hi everyone, welcome to another video on ISTQB Test Automation Engineer Certification. In this video, we will start with an introduction to TAA design and we'll list all the principal activities. Then we will discuss first two activities in detail. They will be capture requirements needed to define an appropriate test automation architecture and comparing and contrasting different designs or architecture approaches. The discussion covers Chapter 3, Section 3.2 of the official ISTQB Advanced Level Syllabus of Test Automation Engineer Certification under the main section of Introduction to Test Automation Architecture Design. So let's start. Before we discuss specifics about these two topics, let's clarify what we meant by test automation architecture design. TAA design refers to the process of planning and structuring the framework and infrastructure for automated testing. It involves determining the approach, tools, and methodologies to be used for test automation. Imagine you are building a house. Before you start construction, you need a blueprint that outlines how the house will be structured and what materials will be used. Similarly, TAA design is like creating a blueprint for automated test project. In TAA design, you are planning the framework and infrastructure for automated testing. You decide what tools and technologies to use, how the tests will be organized and executed, and how the overall automation process will function. When it comes to designing a test automation approach, there are several key activities we need to consider. Let's have a look at those activities. We have capture requirements needed to define an appropriate TAA, compare and contrast different design architecture approaches, understand SUT technologies and how these interconnect with the tests, time and complexity for a given testware architecture implementation, ease of use for a given testware architecture implementation, understand the SUT environment, and identify areas where abstraction can deliver benefits. There can be fewer or more activities required for each test automation project, and it depends on the nature and complexity of the project and the organization. Also, the order in which these activities are carried out can vary depending on the specific requirements of the project or organization. For instance, in some cases, it may make sense to focus on tool selection and environment setup early on, while in other projects, getting straight to test script design and execution may be the best fit. Another important point is that the complexity of the TAA can influence the number and depth of these activities. In this video, we will discuss two of these activities as highlighted here. So let's start discussion about the first activity, which is capture requirements needed to define an appropriate TAA design. Just like any other software development project, successful test automation project starts with identifying and capturing requirements. This process involves understanding what needs to be achieved with the test automation. By capturing requirements upfront, we lay the foundation for a successful test automation project, and it helps us define clear goals, set expectations, and ensure alignment with the stakeholders. The first requirement to consider is which activity or phase of the test process should be automated. This could include test management tasks, test design activities, test generation processes, or test execution activities. For instance, if we are automating test execution when designing the test automation architecture, we'll need to focus on designing and implementing test scripts to verify the functionality of the software under test. Next, we need to determine which test level should be supported by the automation. This could range from component level testing to integration level testing or system level testing. For example, if we are automating component level testing, we'll need to ensure that our automation solutions can interact with individual software components and verify their functionality in isolation. Next is the type of tests to be supported. It is also important to identify the type of tests that the automation solution should support. This could include functional testing, conformance testing, interoperability testing, and any other specific types of tests required for this project. As an example, if we are automating functional tests, we'll need to design test cases that validate the software behavior against the functional requirements. Additionally, we need to specify which test roles the automation solution should support. This could include test executors, test analysts, test architects, test managers, or other stakeholders involved in the testing process. This also depends on the complexity of the project and available resources. Another crucial requirement is to define the scope of the automation solution in terms of the software products, product lines, or product families it should support. For example, if we are automating tests for a product family with multiple variants, we'll need to ensure that our automation solution can accommodate the variations and differences between the products. Lastly, we need to specify which system under test technologies the automation solution should support. This ensures compatibility with the technologies and platforms used in the software being tested. For example, if we are automating tests for a web application, we'll need to ensure that our automation solution can interact with the web technologies such as HTML, CSS, JavaScript, and various web browsers. The second key activity for TA design is compare and contrast different design architecture approaches. As test automation engineers, it is crucial for us to understand the various approaches available for designing different layers of TAA. One of the key responsibilities is to assess different design architecture approaches and select the most suitable ones based on project requirements, constraints, and objectives. By carefully evaluating the strengths and weaknesses of each approach, test automation engineers can make informed decisions that contribute to the success of the automation initiative. Also, as automation engineer, it is crucial for us to weigh the pros and cons of various design approaches when crafting the TAA design. Each layer of the TAA, whether it is the test generation layer, test definition layer, test execution layer, or test adaptation layer, presents unique challenges and opportunities. Next, we will discuss considerations for each of these layers in detail. So let's start from the test generation layer. Before I begin explaining the considerations, let's quickly revise what is test generation layer. The test generation layer is responsible for generating test cases based on defined criteria and requirements. It involves selecting between manual or automated test generation, choosing the appropriate test generation strategy such as requirement-based, data-based, scenario-based, or behavior-based, and managing the challenge of test case explosion. When designing the test generation layer of the test automation architecture, there are several considerations which come into play. Firstly, Test automation engineers must decide whether to opt for manual or automated test generation. While manual test generation offers control and precision, automated test generation can significantly increase efficiency and coverage. Next consideration is that test automation engineers need to choose the appropriate test generation strategy, such as requirement based, data based, scenario based, or behavior based approaches. For example, in a requirement based approach, tests are derived directly from specified requirements, ensuring alignment with the project activities. Additionally, selecting the right test selection strategy is vital to manage the challenge of test case explosion. For example, in a scenario where multiple input parameters needs to be tested across different conditions and configurations, the total number of possible test cases can multiply rapidly. This phenomena can pose a significant challenge for the test automation efforts as it becomes impractical and resource intensive to manually create and manage a large number of test cases. Test automation engineers must navigate practical coverage criteria, risk assessment, and the challenge of managing test case explosion. Practical coverage criteria help prioritize tests based on critical functionality, while risk assessments ensures that high risk areas are thoroughly tested. In the test definition layer, test automation engineers define the structure and content of test cases. This layer focuses on how test cases are designed and documented. Now let's discuss the considerations for the test definition layer. First one is test automation engineers must evaluate the suitability of different test definition approaches, such as data-driven, keyword-driven, pattern-based, or model-driven approaches. Each approach has its own set of advantages and challenges, and the choice depends on factors like test complexity and maintainability. For example, data-driven testing allows for the reuse of test cases with different data sets, while keyword-driven testing enables testers to write tests using natural language keywords. Furthermore, test automation engineers needs to consider the notation for test definition. When test automation engineers define test cases, they need to choose how to represent them visually. This representation is called a notation. Think of it like choosing the format for a recipe. You can write it in a list, a table, or even as a step-by-step instruction. Whether using tables, state-based notation, scenario-based, or others, selecting the appropriate notation ensures clarity and consistency in test design. Choosing the right notation ensures that everyone on the testing team and other stakeholders understands the test cases the same way, and it's like speaking the same language within the whole team. Additionally, adherence to style guides and guidelines is crucial for defining high quality tests. These resources provide standardized rules and recommendations for defining high quality tests. They cover aspects like formatting of code, naming conventions, structure, and related documentation. By following established best practices, test automation engineers can create tests that are easy to understand, easy to maintain, and easy to execute. Also, choosing the right test case repository, whether spreadsheets, databases, files, or it may be a software based tool, for example, Git, facilitates efficient test management and version control. As test automation engineers, it is our job to help choose the best way to define test cases. That means deciding how to write them down and organize them. We have to make sure that whatever approach we pick matches what the project needs and the goals we are trying to achieve. In the test execution layer, the test automation engineers execute the defined test cases and collect results. This layer focuses on the implementation and execution of test procedures. Let's now discuss the considerations of the test execution layer. The first one is test automation engineers must make critical decisions regarding tool selection, implementation approach, and technology choices. The selection of the test execution tool is paramount as it directly impacts the efficiency and effectiveness of test execution activities. Next one is, depending on the chosen test execution tool, test automation engineers must decide between interpretation and compilation approaches for implementing test procedures. This choice often depends on factors like tool capabilities and performance requirements. Similarly, the implementation technology for test procedures play a significant role in determining the flexibility and scalability of the automation solution. Whether opting for imperative, functional, object-oriented, or scripting languages, test automation engineers must align their choices with the capabilities of the chosen test execution tool. Also, selecting helper libraries to ease test execution, such as test device libraries or maybe encoding or decoding libraries, can streamline the automation process and enhance productivity. In the test adaptation layer, test engineers ensure seamless integration between testing activities and the system under test environment. Let's discuss the considerations for the test adaptation layer. So, test automation engineers are responsible for selecting the interfaces to the system under test, choosing tools for stimulating and observing test interfaces, monitoring tools for the SUT during test execution, and tools for tracing test execution. By carefully choosing test interfaces and monitoring tools, test automation engineers ensure seamless communication and interaction with the software under test. Additionally, tools for tracing test execution provide valuable insights into the timing and performance of test activities, enabling better analysis and optimization. One important aspect of tracing is capturing timing information, such as how long each test takes to execute. This allows test automation engineers to analyze performance metrics, identify bottlenecks, and optimize test execution speed. With detailed reports and metrics, test automation engineers can make informed decisions to optimize test execution and improve overall efficiency. And this concludes our topics for today's video. Thanks for watching the video. Please like, subscribe to stay updated on similar content. See you next time in another video on software testing.